So first of all, thanks for joining by to our meetup. So I'm Ruben. I'm a JavaScript engineer here at Zalando. So what we are going to talk about. So we are going to give a quick introduction about unit testing for those who don't know. We are going to talk about some tools that we are using, like for instance, Jest and Enzime. And we are going to talk a little bit about other topics as well. So, first of all, who here tests front-end code on a daily basis? Yeah, you test as well, Zalando people.
Every day.
Okay, cool. So,
It's every day, bro.
so in backend environment, at least from my experience, we tend to have for granted backend tests. So we already know that the guys who are implementing backend, they will do, or they must do at least, unit testings on backend. Why? Why we just do this on the backend, and why don't we do that on the front end? So we are, since now with that new technologies, right, like React and stuff, we are pushing our front ends even more. So we tend to take more logic now into the front end side of the things. And even that we tend to lack in our unit testing environment. So we need to think that you are using someone else's code on a daily basis. Like for instance, you guys, if you use React, React is tested and you are comfortable when you are using it. So if you are sharing your code, why aren't you doing the same? So it's a weird concept. So maybe you have a library of components that you share among your company. And like for instance, if I do a component and if my colleagues want to consume it, they don't want to test it again. They want to be, okay, this works just fine as I'm waiting. And maybe you are trying to achieve continuous integration. So for those who don't know, continuous integration is the routine of continuously pushing code into a master branch, for instance. And this is, for me at least, the best reason about doing unit tests on a daily basis now. So since I use React, let's speak about Jest. So Jest is a test runner like Mocha, Shy, that kind of stuff. It's created and used in React. It was created by a Facebook team. So it's really, really fast when you are trying to run the tests. And one important thing, it has a really powerful mocking library that we are going to speak about soon. So in this case, we have a describe, it, and expect. These are the three main words that you need to know in order to make a unit test work. So a describe here creates a set of a test, like for instance, render tests. And the it, it's the test itself. Then you just create the expectation about what you're waiting for. Here, you expect true to be true and hope that works. So about Enzime. And unlikely Jest, this provides a set of utils that helps you writing your tests. Like for instance, you can imagine jQuery. Who knows jQuery? Okay, so this is jQuery, but for the unit testing environment. And React team recommends using it over their tools. Here you have a simple example. So you maintain the describe and the hit, and you are compiling your component with this word here, shallow. So what this enables is compiling this component into an HTML format. So there are two main features here in Enzime, is shallow and mount. Shallow basically compiles only the component itself, while mount compiles all the children that the component may have. So let's discuss a little bit what you guys think that makes a good test. So at least for me, a test must be fast to run. So anyone?
Not flaky.
Not flaky, okay as well. No one else? you don't do unit tests. So the test can't break for whatever reason. Otherwise, we are not trusting ourselves in the test. It must detect also unwanted changes. So why do you need a test if it doesn't detect anything? Also, if you find a bug within your code, please write a test for it so it doesn't appear again. So here, for those who are familiar, this is a simple React example. So you return an H1 with the words hello world inside. So that's very simple. So here, without using Enzime, you can test the component itself. So you import the React test render. This is from the React team. And then you expect, and the render.create creates a string of the HTML. And then you make a thing called toMatchSnapshot that we are going to speak about soon. So here it's a simple example with Enzime. The only thing that changed here was the shallow thing. So what the heck is a snapshot? So this is maybe one of the most controversial features within unit testing community. In this case that we are talking about, it basically compiles the React component and writes a file called a snapshot. On the first time that you are running, it creates the file, and on the second one, it compares the file. So it can see for differences. So this is a simple snapshot example. So it's the HTML component rendered itself. So imagine that I make a test for a button, for instance, and I commit that file and that test to my GitHub. Then my colleagues download the code and they run the test. Okay, everything works fine. But now imagine that you change the component. Like the component now will return an hello world too. So you don't need to change the test specifically, but you can see that the output of your component is very different. So this feature was mostly created for this type of tests. And you can rebuild it again, and it will write the test again with the correct output if you want to. So since this might lead to unwanted changes, where can we use this? At least from my experience, you can use it when you are testing small components and isolated ones, when you know specifically what you are going to output. But in the other way, I wouldn't suggest for you to apply these type of tests in every JavaScript file that you have. Why? Imagine the project itself, very big. If you have snapshots everywhere, if you change, like for instance, a button in such a nested folder, it will trigger all the things back. So the tests are not so useful for that, and people will start to ignore it. Coverage. So in the community, there's a sense of that we need a percentage in our tests. So for instance, my coverage must be 100%, or my coverage must be 800%. Do you code for 100% coverage? So I think coverage is way more than that. So I think we don't need to go straight to the numbers, because if we want to test just to gain percentage on coverage, we can test, like for instance, constant. They are the same output everywhere. So I think we really need to measure what we are testing. Maybe it's better to have low coverage, but really test something. So if you are using Jest, maybe you already found this. This is basically, this tool is called Istanbul, and basically tells you where are you failing when you are doing your tests. So for instance, the red thingy means that you are not entering on that function. So you are not testing specifically that function. While the yellow one, it means that you are not entering that condition. So from a UI perspective, this is really cool, so you can see what you are missing. But in other way around, maybe you don't need to test that function. So, TDD. I used TDD in the past, but not for React components. In my case, it was for Redux components. So personally, I think there is no actual benefit of doing TDD in React components with this snapshot approach, since the test will basically do that for you. So in my opinion, I wouldn't recommend to do that. Anyone tried this, TDD in React components? Yes? Okay. I'm not talking about logical components, but UI components. So, some tips and tricks. Enzime to JSON. When you are using Shallow and Enzime, for instance, when you are compiling to a snapshot, you will see that what is outputted in the HTML in the snapshot file, it's not HTML. It's just a JavaScript tree with the component itself rendered at. So you can't really read the file itself. But if you use this package, you can actually read it as an HTML output. So instead of having the JavaScript tree about that component, you will just have the HTML inside. So target your mocks. In Jest, you can mock your code. Like for instance, imagine that you are using an outside component. You can mock that component so it's not triggered, or you won't just have to return a div. But a problem that might appear when you are using this is to mock everything. So imagine, for instance, a random function. It will not work when you are creating a unit test for that. Why? It generates a random number. That's OK. Maybe you don't need to mock the whole math library, but you can spy on the random function and return a value. So people, at least from what I see, tend to mock everything because they don't want side effects or anything else. But if you are mocking everything, are you really testing anything? So, structure your tests. That described thing that we talked about composing your tests. So, imagine that you are working on a code base of UI components. You have all the components, buttons, tables, etc. And you are changing code inside of each of one. If you are not familiar with the code, you tend to lag on what tests are you writing. So you could create, at least from my experience it worked, like 3 major describe functions. Like for instance, render methods. Okay, let's see if our components are all rendering as we want to. Lifecycle events, for instance, and other types of tests like unit tests and that stuff. So when you are going to other components, you don't feel the pain of looking to anything new and losing time understanding that. So we already talked a little bit about shallow and mount, but the main purpose here when you are using Enzime, it's to find the right balance between using those tools. So as I said, shallow only renders the component itself, and mount compiles everything. But for instance, mount is very useful when you are testing React lifecycles, and shallow is not that good. Although you like it, mount is slower, shallow it's faster, but they are doing different things. From my perspective as well, people tend to just use one of their choice in a huge code base. So we must be careful about this because they are doing different things. So use and abuse of describe and it. So if you are creating tests, be verbose when you're writing them and create sections of your tests. So when you are running your tests, you can identify if something is going bad in what specific test. Otherwise, if you have one describe with one it, you can't debug anything and you don't understand anything. And one last thing, manual testing and the pyramid of testing. So we are just talking about the unit testing environment, but there are other steps, like for instance, integration tests and UI tests. And as the pyramid goes up, the tests tend to shrink. Why? Because maybe you don't need that much of UI tests, and they are slower as well. Who here used Selenium in the past? Okay, you know what I'm speaking. So we need to find the balance between having tested code in unit tests or doing that in other type of staging. And that's what I was about here speaking. Thank you.